Alright, let's do one where, let's find the cost function where the fixed cost is $100 and the total cost to produce 80 items is $1,700. So we're given a little bit different information here. We're told the fixed cost is $100, so B is $100. The total cost to produce 100 items is $1,700. And I'm going ahead and writing this using the notation, using point notation, calling B our y-intercept, our fixed cost. I already called it B up above, so hopefully that shouldn't be too much of a stretch. But the cost to produce 80 items is $1,700. If X is 80, Y is $1,700, or the total cost is $1,700. So hopefully this should look something like what we've done before, although this is still a little bit different information. Let's think about our y equals mx plus b equation that we've seen before. Well, before we were given a slope and a point. Here we're actually given a y-intercept and a point. So you could look at this in two different ways. You could say y equals mx plus b, and I'm going to plug in this value for y, this value for x, and this value for b, and then find out what m is. That would actually work out just fine. Alternatively, you could say, well, this is my y-intercept. This is actually a point. This is the point 0, 100. So that means I could use my slope-intercept form. M equals y2 minus y1 over x2 minus x1. Either way works here. Let's do the slope, because I feel like that's probably a little more natural. But over 80 minus 0. This is 1600 over 80, which gives us, what is that, 20? Yeah. If I'd done it this way, let's see how that would work. We get 1700 equals m is unknown, x is 80, plus 100. Let's see, I'd subtract 100 from both sides. 1600 equals m 80. Not the firecracker, M80. Divide both sides by 80, and we get m equals 20. You can see we get the same slope for both of these. It's just a slightly different way of going about it. We're looking for the cost function. We already know the fixed cost. We now know the slope. So the total cost function here is going to be 20x plus 100.